Well, hello guys, here Mr. G with another video, this time for the grade 11s, and we're going to do an equation on redox reaction. I'm going to leave the equation in the description below so you can answer before watching the video, and don't forget to subscribe to the channel so you can get all the videos I post on regular basis. This question said consider a balanced redox reaction, and 7.1.1 define oxidation. You have the reaction. We can say that oxidation is the loss of electrons, and that will give you 2 marks. Alright? So now, the next question. From the balance equation above, write down the reduction half reaction. Now, to do this one, we need to know which substance is being oxidized and which one is being reduced. So let's write down the oxidation number for each of them. Copper, for instance, in this case have 0, according to one of the rules. If you go there, have a 2 plus, or positive 2. If we carry on, silver here have a positive charge, positive 1, and it have a 0 on this side. So we're going to copper first. You see that from this point to this point, the oxidation number increases, so it's being oxidized. So copper happen oxidation. Copper is being oxidized, and therefore you're going to see silver. Let's just change the color to see a difference there. You can see silver here, the oxidation number decreases, therefore is reduced. Copper is being reduced. So let's write down the half reaction for both of them. It's not that difficult for copper and for silver. So if you come here, this is question 7.1.2. Okay, so let's go to oxidation. Now, note the following, guys. They ask you only for reduction, but we are going to do both just to practice. So for copper, what copper does? Copper, you come here and you started with copper 0 and you go to 2 plus. So it's Cu, right? It's going to Cu 2 plus. So now you have to balance the number of atoms there, it is balanced, and now you have to add electrons to balance the charge. So we're going to add electrons always to the most positive side, which is in this side, and we have to balance. So it is 2 positive, we have to add 2 electrons, and that will give us the correct half reaction. This one is the half reaction for oxidation. Okay, now alternatively, you can come to the table of reduction, standard reduction. In this case, I like the second table, but it doesn't really matter. You can use either one, it's the same one. So if you use this second table, you need to know that oxidation is always going to be written from right to left. Okay, so for example, you go to look for copper, you make sure is that copper 2, no, copper plus is copper 2, is this one here. So you can see it there. We are going to write it in that direction. In other words, you are going to say Cu 1 arrow, Cu2 plus 2 electron, as it is there, but in that direction. And that one is the oxidation half reaction. Now, for the reduction half reaction, we are going to do for silver. Okay, so for reduction. So now for reduction, we're starting with a silver positive and we're going to silver 0. So it's Ag plus, and on the other side you have Ag. All you have to do is to balance the atoms, which is balanced, and then add electrons always to the most positive side. We have to add 1 electron, and that is balanced. This one is going to be the reduction half reaction. This one is the question, and then you will get 2 marks for that. Now, alternatively, if you come there to the table where we were speaking, you can use either one, but if you use the second table, then reduction is going to be written in the other direction, in that direction. Okay, so you go and look for silver, which is right here, and then you write it as it is there. Ag plus 1 electron will give you Ag. Only remember also that there's only 1 arrow for both of them. You cannot do the double arrow as it is in this table. So very simple. Oxidation, you write it from right to left. Reduction, you write it from left to right. And I am using the second table. I'm using the 4B table. That is quite simple. I hope you understand, and it's quite important for grade 12. Okay, so that's it. Now write the formula of the reducing agent. Now you need to know that the reducing agent is the substance responsible to make another one to be reduced. In this case will be copper. Copper is responsible for silver to be reduced. So all you have today to say is Ag, because they want the formula. Sorry, Cu. I just say Cu. Cu is the reducing agent because it's the one responsible for make silver to be reduced. Silver is being reduced, but is the oxidizing agent. Okay, so question 7.1.4, explanation of the answer in question 7.1.3 by referring to the oxidation number. So all we have to say here is the oxidation number increases. And that will be the answer. The oxidation number of copper increases, and that is high is the reducing agent. Question 7.2. The following incomplete chemical equation represented redox reaction. And then you have this one. Now, this one could be tricky if they tell you if it's either in an acidic or basic medium, then you'll have to start adding either water or hydrogen ion, etc. But in this case, they don't tell you anything about that. So what we're going to do is to use this table, and it's quite simple. First of all, determine the oxidation number of Cr in Cr2O7. So let's do that calculation real fast, and then let's do the balancing equation. So let's calculate the oxidation number of that substance. I think we have space here. Let's do it on this side here because I want to use that one for the next one. So we have Cr2O72 minus. So do we know that if we have this one of the rules of oxidation number say that if you add all of them, you have 2Cr plus, let's say, 7 oxygen will be equal to minus 2. And then you have oxygen. So it's 2Cr, which is what we are looking for, plus 7 oxidation number of oxygen is always negative 2, and all that is equal to minus 2. This minus 2 is coming because it's the charge of the ion, that is that minus 2 there. And the rest is just a mathematics. So we have the 2Cr minus 14 is equal to minus 2. When you rearrange, you have 2Cr is equal to 14 minus 2, it's 12. Then Cr is equal to 12 divided by 2. Cr is equal to 6, and positive 6, that is the oxidation number. And you will get 2 marks by that answer. You don't have to stress too much. Now use the information in the above standard reduction potential. Now they're telling you to use the table and write out the balanced net ionic equation. Clearly indicate the following: reduction half reaction, oxidation half reaction, and balanced net equation. So now the first thing we're going to do is to identify which one is being oxidized and which one is being reduced. That is the first important thing, because when we go to the table, to this specific table I speaking about, the second table, we know that if it's oxidation, we're writing from right to left, and if it's reduction, from left to right. Remember, using the table 4b, not the first one. The first one is the other way around. Okay, so we go here and we identify. Let's see, we have the families are the following. This substance is family of this one, and ion is family of that one there. In the case of ion, you can see that the oxidation number increased from 2 plus to 3 plus, and therefore is oxidized. So this one is oxidation. Alright, so we know now which one is oxidation. And Cr, you can see that Cr has first positive 6, and then at the end have 3 plus, so it's reduction. So this one here is reduction. So now, very easy. All we're going to do is to look for the half reaction for both of them in the table. We have in Fe2 plus to Fe3 plus. So be careful with that one. That one is the oxidation. Okay, so let's write down the equation here. This one is question 7.2.2. We're looking for ion 2 to ion 3. So we go here to the table, the second table, and we're looking for ion 2 to ion 3. Be careful because there's another ion here, you see, but this is not the one we are looking. No, we are looking for ion, there is another one here, so be careful. There's a couple of ions, so you have to look very careful. Don't you make a mistake. And guys, here is the one. Here is the one. Now it is oxidation. This one is the one. Let me mark so you can see it. Here is the one we are working with. Remember, going back, ion is being oxidized. So we are going to write from right to left. So it's oxidized, therefore we write from right to left. So it's Fe2 plus and then the rest. So it's going to be like this one here, nothing to stress about. Fe2 plus, one arrow, Fe3 plus one electron. It is exactly as you can see it here in this specific table. I'm writing in that direction, all right, starting from Fe2 plus. That's all I'm doing first. That is already the oxidation half reaction, and if you do that, you'll get 1 mark because they're asking you to show. Let's go to the reduction. Now reduction, we have in the Cr2 on one side and on the other side Cr3 plus. So we are going to look for that half reaction, and it could be a little bit tricky. Now Cr, no, this one, remember it's not just Cr, ne? So it's not that one there. Looking for it, we are looking, there we go. This one is the one we have here. You can see on one side, you can see the Cr2O7 2 minus, like it is here. On one side is the Cr2O7 2 minus, that is what I'm looking for. And on the other side you can see the Cr3 plus. That is what I'm looking for, nothing to. But now we are going to write this equation because it's reduction in that direction. So it's going to be exactly as it is there. It's going to be Cr2O7 2 minus plus 14 H plus 6 electrons, 1 arrow, remember only 2 Cr3 plus 7 H2O. That is the half reaction we are going to be writing there. Okay, so we are going to take it from here all the way up. Let's say copy, and let's move it all the way here to this side. Here, let's paste it here. And now this one is the reduction half reaction. Let's maybe write it here. Reduction. Okay? This one is oxidation. And guys, we're almost done. We already have the 2 half reactions, and therefore you will get 1 mark for each of them. Now the rest is quite simple. We have to make sure the number of electrons are the same. So they need to have this number of electrons the same. How can I solve that problem? Mathematics. I'm going to multiply the first one by 6. That's all. Everything multiplied by 6. So I will get 6 Fe2 plus 6 Fe3 plus 6 electrons. And then I'm going to work with these 2 equations like if they were mathematical equation. I'm going to equate, I'm going to work with everything. So I'm going to add everything on the right, on the left together, and everything on the right. So in other words, I will have, and I'm going to add, let's just draw a line here so you can see the difference of what I'm doing. I'm going to say Cr2O7 2 minus plus 14 hydrogen plus 6 electrons. Now that one was the first equation. I'm going to the second one, plus 6 Fe2 plus, and I'm going to draw the arrow. Now I'm going to add everything that is on the right side. 2 Cr3 plus 7 H2O plus 6 Fe3 plus 6 electrons. Now you can see the electrons are on opposite sides. They are common factors, so the electrons cancel each other. You can see here these electrons cancel each other. And then we have the net equation. All we have to do is to write that one without the electrons, and then the answer will be Cr2O7 minus plus 14H plus 6 Fe2 plus, one arrow, 2Cr3 plus 7H2O plus 6 Fe3 plus. The order in which you write in those different pieces is not really a big problem. And then this last equation will give you 2 marks. Guys, this is the end of the question. I hope it helped. It's a very good question to practice on redox reaction. Thank you for watching. Thumb up. I'll see you next time. Mr. G.